here. And now Trevor Smith, Business Development Manager from Pico Technology, will give us an overview of the products and news the company is launching here at the show. Please go ahead.
Okay,
Trevor.
so thank you very much, Wolfgang. So I'm Trevor Smith. I'm Business Development Manager at Pico Technology, and you've probably heard of us. We make PicoScopes. So PicoScopes are being used very widely by designers of embedded systems. PicoScopes are a little bit different to traditional benchtop scopes. So if you have a PicoScope, there is no screen.
Yep.
There are no knobs to turn. So the PicoScope works in conjunction with a laptop computer. So the connectivity is through a USB port, and the controls to the scope are through the laptop computer, and the display of what it can do is also on the laptop computer. So what we've done in recent times is to extend the range of PicoScopes. So at the end of 2013, we launched the pocket version. So the PicoScope 2200A is a very powerful 2-channel oscilloscope with an inbuilt arbitrary waveform generator. But it can literally fit in your pocket. You can take it anywhere in the world, but it gives measurement capability up to 200 megahertz with 48 kilosamples of buffer memory and pretty advanced analysis tools for serial bus decoding and segmented memory and so on. At more or less the same time as we introduced the 2200, we also had the launch of something that is absolutely unique in the industry. It is the PicoScope 5000 series. So the 5000 series offers 4 oscilloscope channels, or up to 4 oscilloscope channels, an external trigger, plus an arbitrary waveform generator. So it's again, it's a bandwidth up to 200 megahertz. Very deep buffer memory up to 256 megabytes. But the real thing that is unique about the 5000 series is that the resolution of the waveforms that it captures is variable. So we can have 8-bit capture of waveforms with very, very precise timing resolution, or we can internally, under the control of the user, reconfigure the HD converters that are inside the oscilloscope to achieve resolution of 12, 14, or actually by sacrificing 2 of the channels to 15, or on a single channel, even to 16 bits of resolution. So those have been around now for a few months.
Now let's talk about the Pico software for the oscilloscopes.
Yeah, so PicoScope software is something that's we've had now for a few years. It's been developed and extended, and is extremely powerful. But it is Windows based. Now, that's fine. There are many people who are very happy with Windows, but of course the community of embedded system developers, something else that's very popular and useful for them is the Linux operating system. So what we've announced at the show this week is a version of PicoScope that runs under Linux. So PicoScope for Linux. The version that we're showing here is the beta version. So all of the basic functionality of PicoScope is implemented. Some of the advanced features like serial bus decoding and some of the math functions will be added in the next 3 to 4 weeks. But we then have 2 versions of PicoScope for both the Windows and for the Linux community.
And where are the differences in is it different to use or different user interface?
It's really down to the preference of the users. So the designers, if they've been in a Linux environment for the the design and the simulation and the development of their product, if they've used Linux as their operating system, usually they prefer to stay in the same environment when they move to do the verification of those designs. So we've really moved to accommodate those wishes.
Okay. So, and you brought a new product with
so
you?
we're very proud of this one. So this is the PicoScope 4824. It's the same size as the 4-channel models, but the new model has actually 8 channels. So it's something again that is unique in the industry. It's 8 channels with 20 megahertz bandwidth and with 12-bit resolution and up to 80 megasamples per second sampling on those channels. So it's a product is not expensive. It's less than 2,000 euros, but offers all of that capability for design analysis, including the waveform generator, so an arbitrary waveform generator, a 14-bit high-resolution arbitrary waveform generator is included in the instrument. It is both connected and powered by a USB 3 interface on the scope. So by connecting the scope to the laptop and transferring data from the scope to the laptop, we get extremely high performance for people who are working on, for instance, sophisticated embedded systems with multiple serial buses. Plus they want to look at the performance of multiple sensor inputs, for instance, and other parts of the system. It's useful for people who are working on power systems, people who are looking at both single-phase and 3-phase systems, where they want to look at the line and the current being drawn on all 3 phases, plus the neutral, or perhaps they want to look at the control circuitry for a switch mode power supply or something like that. So 8 channels is something that's until now has been pretty rare, but increasingly we see a need for that.
Okay. Yeah, it's a new product, but I would like to ask you, what is the future for Pico oscilloscopes?
Okay, so Pico oscilloscopes. So what we're presenting today gives actually quite a few clues as to where we're going in the future. So, of course, engineers always have been expected to deliver faster designs. So that we pay attention to the needs of the bandwidth. So 200 megahertz might be enough today. Probably they'll need 300, 500 megahertz in the future. Who knows? Perhaps a gigahertz. More resolution. So that's been a big change in the past couple of years, where people were using previously digital oscilloscopes primarily to characterize the timing relationships of channels in digital designs. With mixed analog and digital designs, they need much more resolution. They need both the speed and the resolution to look at those two characteristics more carefully than they needed to do so in the past. And with binary signaling, with low voltage differential signals, then the noise and jitter become an important part of a communication stream. So the bringing scopes to market with more speed, more resolution, lower noise, that's kind of indicated by what we're doing with the 2 products here today, give big clues about what you can expect from us in the next year or 2.
Okay, thank you very much.
Thank you.